Hi everyone, I am Likita and this is the video of my presentation of my internship at EMERTXE and internship. So the project title is IoT Based Home Automation Solution. Table of contents. What I learned during this internship. I have learned C programming, C++, introduction to embedded systems, introduction to IoT, project implementation, project overview, project requirements, project design and conclusion. So coming to C programming, we have taught C programming in the initial week of the internship, and in that we have learned Introduction to C, basic data types, if and else conditional statements and loops, arrays, pointers, functions, strings and storage classes, preprocessor directives that are as include and as define. Next is the C++. So basically C++ is the extension of C that we used in programming the Arduino in the Arduino IDE. So in C++ we have gone through introduction, POP versus OOPS, that is procedure oriented programming versus object oriented programming, and C versus C++, classes and objects, access specifiers, inheritance, types of inheritance, polymorphism, function overloading and overriding. Next, introduction to IoT. So, since this is an IoT internship, we were taught about IoT and IoT devices. The IoT stands for Internet of Things. So, the Internet of Things refers to a network of interconnected physical devices such as sensors, vehicles, appliances, and other objects that are embedded with software, sensors, and connectivity to collect, exchange, and act on data over the Internet or other communication networks. This is the important features of IoT. IoT devices are well known for their connectivity, sensing, data processing and analysis, automation and control, scalability, security, interoperability, energy efficient, remote access and monitoring, intelligence. Next is the embedded systems. An embedded system is a computer system designed to perform a specific function within a larger device. So it combines hardware and software to carry out dedicated tasks, often in real time. So the systems have classified into two groups based on their performance and based on the performance of the microcontroller. So based on performance and functional requirements, embedded systems are classified as standalone embedded system, real-time embedded system, networked, and mobile embedded system. Same way, on the basis of performance of microcontroller, they are divided as small-scale embedded system, medium-scale embedded system, and sophisticated embedded system. These are the examples of embedded systems that we go through in our day-to-day life. They are smartphone, cars, printers, machines, television, camera, and many. These are all designed to perform specific tasks, hence they are called embedded systems. Next, coming to the project implementation part, project overview. This project aims to design and simulate a smart home automation system using the picsimlab simulator integrated with the blynk IoT mobile application. The system enables remote monitoring and control of key household functions, including lighting, temperature regulation, and other water tank management. User can control the home lights, monitor and adjust the temperature, and also manage the inflow and outflow of water in the water tank directly through the mobile app, that is blynk mobile app. The simulation demonstrates an efficient and user-friendly IoT-based solution for enhancing home comfort, resource management, and energy efficiency. Coming to the project requirements. So my project is entirely implemented in picsimlab using Arduino IDE. Next, the major requirements are Arduino Uno, blynk IoT app, and other in the three parts of the project, there are LDR sensor, lights, CLCD, temperature system, blynk IoT app, water tank, and again blynk IoT app and CLCD. So basically, CLCD and blynk IoT app are the common requirement for all the three uh, parts of the project. Next is the Arduino IDE. No, Arduino Uno. The Arduino Uno is a popular open source microcontroller board based on the Atmega 328P microchip. It is widely used in embedded systems and IoT projects due to its simplicity, versatility, and affordability. Since Arduino Uno is easily programmable, this is widely used and it provides 14 digital IO pins, 6 analog pins, a user interface, that is a USB interface, and supports programming through Arduino IDE, making it ideal for beginners and advanced developers alike. Next, functionally, the Arduino Uno serves as the central controller in a system. It reads input from sensors, processes the data, and controls output devices like relays, LEDs, and motors. It can also communicate with other devices or cloud platforms using modules like ESP8266, that is a Wi Fi module, Bluetooth, or Ethernet Shield. In the project, I have used Ethernet Shield to interface between Arduino IDE and blynk IoT app. Next, the first part of the project is guardian lights control. So this is the block diagram of the guardian lights control. This is Arduino Uno LDR sensor, and these are the lights. So what it does is it reads the LDR sensor value. Based on the reading from LDR sensor, the brightness of the guardian lights will be vary. This which resembles controlling guardian lights based on the availability of the sunlight. So an LDR sensor is the light dependent resistor. This is a light sensitive sensor whose resistance decreases as the intensity of light increases. So when the LDR value is high, we can see the guardian lights will glow very brightly. CLCD. This is the common requirement of the project, and it is used in temperature system and as well as water tank control. A character LCD is a display module used to show alphanumeric characteristics and basic symbols in embedded system. It typically comes in formats like 16 by 2 or 20 by 2, meaning that 16 lines and 2 columns, or else 20 lines and 4 columns. This is how the CLCD looks like in the provided in the picsimlab. Temperature control system is a second part of the project, and the temperature control system consists of a heating resistor, an LM35 temperature sensor, and a cooler, which resembles the temperature control system at home. Read the temperature from the temperature sensor LM35 and display it on the CLCD. So basically this is a block diagram of the temperature control system used in this project, and here we have Arduino Uno, temperature system, CLCD, and blynk IoT application. When the Arduino reads the temperature from the temperature system, it is displayed on the blynk IoT app, and the same is displayed on the CLCD. Based on this displayed temperature, the user may monitor the temperature system. He can on or off the heater or the cooler through the blynk IoT mobile application. So this is a summary of the temperature system. Next, we have the four controls in this. So, temperature control system. Here, this temperature sensor reads the temperature and display it on the CLCD. Based on the display temperature, the user can control it by cooler control system or heater control system. That means when the button is on, the cooler turns on, and when the button is off, the cooler turns off. Same happens with the heater control system. When the button is on, the heater turns on, and when the button is off, the heater turns off. Here I have put a threshold temperature control. If the temperature exceeds 35 degrees Celsius, the heater is turned off automatically and a notification is sent into the blynk IoT and also it is displayed on the CLCD. This is how temperature system looks in the picsimlab. This is the temperature system and I have connected heater, cooler and temperature sensor. Here we have LM35 built-in temperature sensor in this temperature system, and this is a CLCD displaying the temperature and status of temperature, status of heater and cooler. Next is third part is the water tank inlet and outlet valve control. So what it does is the read the volume of the water in the tank through serial communication and display it on the CLCD. Control the volume of water in the tank by controlling the inlet and outlet valve by sending commands through serial communication. This is the and this displays the volume of water in the tank on CLCD. So this is the block diagram of the water tank system. We have blynk IoT, Arduino Uno, water tank and CLCD. So as soon as the Arduino reads the volume of water from water tank, it displays the same volume in the blynk IoT app and also in the CLCD. Based on this based on this volume of water, the user will monitor inlet and outlet valve control. Either if inlet valve is on, the inlet valve will be on in the water tank. Same happens with the outlet valve. And this is the summary of the requirements and the controls in the water tank system. So, first, the volume of water in the tank is displayed on the CLCD and blynk volume gauge. Then, inlet valve control. This enables control of inlet valve through the blynk IoT mobile app using a button widget. If the button is on, the valve is on. In the same way, if the button is off, the inlet valve is off. Same happens with the outlet valve control. If the outlet valve is turned on, then the outlet valve is turned on. If the button is turned off, the outlet valve is turned off. Next here the control of volume of water in the tank. So to automatically maintain the desired water level without the human intervention, I have put the automatic programming that if the water volume falls below 2000 liters, the system will turn on and the inlet valve will be on. This notification and this intention is sent to CLCD and as well as blynk IoT app. This is how the serial remote tank looks like in picsimlab. This is the inlet valve, this is the outlet valve, and here we can see the volume displayed on the screen. The same value is displayed again on the CLCD and the blynk IoT app. So blynk IoT app. This is the user interface app. It acts as a bridge between the Arduino Uno and the user. So, Blynk was designed for the Internet of Things. It can control hardware remotely, it can display sensor data, it can store data, visualize it, and do many other cool things. So, I have created 4 button widgets to control heater, cooler, inlet valve, and outlet valve. Gauge widgets to display temperature and volume of the water. This is a picture of blynk IoT application. This is how in our mobile phones it looks like. Since I have created 4 button widgets, these are the 4 button widgets and these are the 2 gauge widgets. Next, this is the project design. So this is the picture of my result. This is a CLCD, this is temperature system, this is a garden light, and this is how a cereal tank is. So the CLCD is displaying the temperature, status of heater and cooler, and the volume of water in the tank. and the inflow and outflow of the water tank. Now I am going to simulate and show you the output of my project. This is the Arduino IDE and this is where I have write the program of this project. It includes all the files separately and these are all initialized in the looping of the main file. Okay. This is the picsimlab. These are the spare parts. I have loaded the hex file in the picsimlab and this is the CLCD. This is the temperature system. These are the garden lights. So first I'm going to show you the garden lights control. LDR value is high and the lights are bright. I am decreasing the LDR value and the lights go off. Again, I am increasing the value of LDR. That means the sunlight's intensity is decreasing so that the LDR value increasing and the garden lights are glowing brighter and brighter. Again, when LDR value goes down, the garden lights are off and increasing. Next part is this temperature system and the serial water tank. This I am going to show you by casting my phone, that the mobile app. So this is the mobile blynk app in my phone. Now I will control the temperature system and water tank inlet and outlet. These are the four widgets, button widgets and two gauge widgets. Now as soon as I turn on the heater, the temperature increases. The temperature increases here on the CLCD and the same is displayed on the blynk IoT app. Now as soon as the temperature reaches the 35 degrees Celsius, it automatically turns off. Heater automatically turns off. Now I turn on to see the cooler. When I turn on the cooler turns on and the temperature keeps decreasing. Here the temperature keeps decreasing. I turn off the cooler now. The off is displayed here and here. Next, I would like to on the inlet valve and outlet valve. When I on the inlet valve, the tank inflow starts and I off the inlet valve is off and it is showing that there is 3000 liters in the tank. Now I will on the outlet valve to see whether below 2000 liters whether my inlet valve will be on automatically or not. Then the volume is going below 2000 liters, then the inlet valve is automatically on. Now I off the outlet valve and as well as the inlet valve. So this is how the home automation system looks like completely. This is the blynk IoT app interfaced with all of these Arduino Uno. This is the cereal tank . And These are the guardian lights controlled by LDR sensor. Now, in conclusion, the home automation system using blynk IoT and picsimlab successfully demonstrates remote monitoring and control of household devices. The system efficiently manages lighting, temperature, and water tank operations through real time data display and control. The CLCD dashboard provides clear status updates of the various systems in the project, so enhancing user interaction. Overall, the project showcases the effectiveness of IoT based automation in creating a smart and connected home environment. Thank you.